Okay, so problem number 2 here, we're given that the rate of change of water depth, again, you can think of water flowing downward in a cylinder, right? Descending in a cylinder, because the hole in it or whatever, is 9 millimeters per second. Okay. Then, clock time changes from t equals 2 seconds to t equals 4 seconds, okay? Well, what do we know? We know if we do a graph, we don't know what the y-coordinate is here or here, okay? But we do know what the t-coordinates are. They're 2 seconds and 4 seconds, right?
Mm-hmm.
And what else do we know?
The interval.
Yeah, we know the rate of change. What's that tell us about the graph?
That the rate of change is.
The slope is.
Right. That's the slope, right?
Yeah.
Okay, so I want you to begin labeling your fundamental triangles by the standard labeling that we have talked about, okay? Which means that you put the slope above the hypotenuse, okay? With a box around it so we know what we're looking at. Don't write it over here. I mean, it's okay if you write it over here, but we want to see it here. We don't want to have to look for it. And we get used to the idea that whatever number is in this box is the slope, okay? And it's a representation that we can use to help focus our thinking and not have to think too much about what we're thinking about, okay? So we need to do that. Okay, well this is nine millimeters per second, right?
Mm-hmm.
That's the rate of change, that's the slope. Okay, well, of course, we're dealing with a situation where we have a fundamental triangle. So what else can you tell me about this fundamental triangle?
Well, we already know the run.
Well, we don't know it, but we can easily find it. What's the run?
4 minus 2?
I'm sorry?
Would it be 4
Yeah,
minus 2?
yeah. Except now we got units, so we want to get in the habit, if the numbers have units, I'm going to write the units. The little s, that's an s, not a 5. And you can get used to this. My s's look like this and my 5's look like this.
Perfect.
See the difference?
Completely.
Well, there really is a difference. No, I didn't write them, so there would be. Okay, so 4 seconds minus 2 seconds, which is 2 seconds, right? Okay? Now, what's the rise? Well,
You just do the run times the slope, right?
we could say that y is depth, right? Okay? Now, we don't know the y-coordinate here or here, right? But we have enough information to figure out the change in the value of y. Okay? So that's the change in y, and that's the change in the depth, isn't it?
Ah, I was making that a little harder than me.
Okay? So if you're totally oriented to the graph and understand what the graph is telling you, you have this simple picture that answers the question. Okay? Except, of course, you still have to calculate the rise, but you know the slope and you know the run. Okay? So how do you calculate this? Well,
Slope times run.
it is But let's write it out this way and then let's talk about that. Okay, so you know that okay, one thing you can do is you can multiply both sides by the run and you get the rise. Okay? Yeah, okay, we'll do it that way. I was going to put the numbers in here, but
That's what I do.
so the rise is the slope times the run, right? Which then equals what? Slope 9 millimeters per second times 2 seconds, right? Well, what do you get if you multiply 9 millimeters per second times 2 seconds? Well, 9 times 2, most of you understand, is 18. Very good. Okay, we're fine with that. And that's millimeters
Per second.
over seconds times seconds. Right? Now, that's a fraction in symbols, right? Millimeters over seconds multiplied by seconds. Okay? What do you get?
18 millimeters.
You get millimeters, right? And we've spent a lot of time working with fractions, so I hope that you totally understand how the fractions work here. Okay? Because it's very important for understanding what things mean. And just in case you're a little fuzzy in this, because people often are, I can say, okay, look, millimeters over seconds times seconds means millimeters over seconds times seconds over 1, which is millimeters
Over 1.
times seconds over seconds times 1, which is millimeters over 1 times seconds over seconds, okay? And your seconds over seconds is 1, so that's millimeters over 1 times 1, which just equals millimeters. In case you need,
Actually, hard.
and you should be able to work that through,
Okay.
okay?
I was making that a lot harder than it needed to be. Got it.
Remember, I'm at least for now forbidding cancellation, because I've seen people do ridiculous cancellations. And often people who did very well in the course are still doing ridiculous calculations. So cancellations, it happens. And it's been my experience that it always happens. We don't do cancellation.
I read it differently, but got the same answer.
You
When we were
you
doing
what now?
those. When we were doing those on our homework, I read it differently and did the equation a lot different, but got the same answer. Like,
As long as you did it correctly, when I take a closer look at your homework,
well, mine was something like 9 and then 9 times 4 minus 2 in parentheses.
okay,
So then you would get 2 and then.
that would follow the definitions.
Okay.
You do want to include the units though.
Okay.
When units are given,
I
you want to
did it on
include
my
them so you
homework.
think about what everything means. Okay? And you want to do the units accurately.